Yeah, MS kinematic and this kinematic.
Same or different?
Same actually. Do MS kinematic, this one do it.
You're going to flip the whole chapter over.
I'm going to flip until every page tear off. Okay, this is because combined science.
Too simple.
Not really. It's not enough to. It's not enough to know what it is.
Huh?
Yeah. It's really not enough. Okay, so since that's the case, I just teach accordingly. Okay. So kinematic.
This is my combined science book.
Yeah.
What the?
It's for 2 years, right?
It looks like pure science.
See?
Yeah, 2 weeks. 2 weeks is good enough. Okay.
2 weeks for 2 years.
2 years like for them. For them to do this.
But, okay.
Okay, we talk about kinematics. We talk about motions. We don't care about who is the one that causes the motions. The one that will cause the motion is in the chapter dynamic, which is the next chapter. Okay.
Okay.
The one that will cause the dynamic is in the next chapter, which is force.
Okay.
So we just care about what do you have in motion. So in the motions you have 5 things.
Kick.
5 things.
The thing move forward.
SUVAT. Okay.
Suvat.
Before you come to this, we do something that you know, which is called distance, speed, time.
Yes.
DST.
Yeah, DST.
Okay. Oh no. Okay. Speed
Why
is
oh
your
no?
distance because you make something too elegant. Okay. So here,
Wait, yes.
don't waste your time again, because we're not going to do all these things. This is what you should know. Okay. Speed is over time. Okay.
Okay.
Tell me, can speed decrease or not?
What do you mean by speed?
Okay. If I have a speed distance time graph, distance time first. This one makes sense?
This
Possible or not?
This
graph.
what's that time?
Time, yeah.
Distance and
When the time goes, my distance keep increasing or
Can,
can, right? Make sense? This one?
yeah.
Okay, right? This one?
No,
Why?
cause you didn't start from zero.
What must I start with 0? Must I start with 0?
Yeah.
Why?
Cause like a car, you start from zero. What? You cannot start from.
So my car has
200.
already my car has a mileage meter. I start with some distance. Can or not?
Can.
Right? I can, right? Okay, so I can. Okay. So can. Okay. How about this?
But the distance is only 0 point something.
How about this?
Can.
Why?
You can start and stop and start again. What? You can 踩油 and then you can brake and then 再踩过.
It's not possible.
Why? Why?
Before you ask why, can you spend some time to think about why? I tell you the fact already.
It's not possible.
It's not possible. The red line for the distance time graph is not possible in this world.
I don't know why.
IQ test your IQ.
This.
Now, before you keep asking why, first accept the fact first. It is not possible. Then you can start thinking about it. Why is it not possible?
Ready.
If you keep thinking about why, then you will never think.
Oh, I understand.
Reason?
Your time, the more time your distance cannot go backward.
You're right. Okay, the distance can never go backward. Okay.
Okay.
So distance got to keep going. The most is stay there and keep going. Okay. It can never turn back. Distance. Okay. Your reverse is still keep increasing the distance that you have walked.
Oh yeah.
Right.
Yeah.
Okay. If you say reverse, no, you're right. Okay. If you talk about reverse, right, your distance actually decrease. That's not distance. That's displacement. Okay. That's displacement.
Oh.
This is what we're going to learn is displacement. So do you understand displacement and distance?
No.
Displacement, this is possible. You can do this also.
Okay. But
Because reverse means, back to original point means the displacement is 0. Okay? Now, for example, object A,
cool one.
move to object B, or move to position B, back to object A.
Yeah.
The
This
total,
displacement,
this is 2 meters, this is 2 meters. The total distance I've traveled is 4 meters.
Uh-huh.
But I know that is the distance kind of thing is like 0. Because I, as if like I never move.
Okay.
Okay? But the so-called, the distance you talk about is actually the displacement. Okay? Distance is 4 meters. Displacement is 0 meter. Okay, you see it?
This is 4 meter.
Displacement is 0 meter.
Displacement is 0 meter.
Yes. When you go here and come back here exactly this point.
Oh, okay.
Okay?
Yes.
So displacement is 0 meter.
Mm-hmm.
Now, when it's A and B in this way, when you go with 2 meter, when you just come back 1 meter,
Displacement is 1 meter.
you're right, displacement is 1 meter, and distance is
Distance is 3 meter.
good, okay? Now, so, last one, okay, if you move from object same place A to B, position B 2 meter, when you come back with 3 meters,
Mm-hmm.
so what's the distance and what's displacement?
The distance is 5 meters.
Uh-huh,
The displacement is
have a good guess.
minus 1 meter.
Good, okay? There's a minus sign for displacement. So the minus sign means the displacement value is negative, or a minus sign indicate a direction.
Direction.
Direction, you're right, okay? You just teach yourself. Displacement is first point, last point, and we normally fix one direction as positive. Anything against that
The other
direction
negative.
is negative. Okay, so that's what for displacement. And that's what for distance. Distance is a cumulative effect. Okay? So good. So this is why I say physics is common sense. Okay? I don't have to teach you, but you actually teach everything yourself.
This 7 you just now is called what? 7.
7 basic dimensions, 7 basic SI unit in chapter 1 there.
7 basic dimensions. Thanks.
Yeah, but try not to waste too much time there. Okay? Even you don't remember as person. Okay, this is what you need to focus.
Okay.
來，不要抄啦，誒明白就行啦嘛。Because the thing is that because just now you raise the idea by yourself.
Mm-hmm.
So by the same instinct, right, you'll be able to reason it yourself anytime.
Mm-hmm.
Okay, so you don't have to remember, it's just by yourself.
Mm-hmm.
Okay? So this is why it's common sense, right? Oh, tell me the slowest speed in the world is what?
Slowest speed in the world?
Yeah,
0.
0. Can I have negative speed?
No.
So, speed like that, okay or not?
Speed. Okay.
Okay or not?
No.
Why?
Speed like that. What's the other one?
Time? No? It's always time.
Can.
Can what? Why not?
Can, right? Can. This one?
No.
No.
No, why?
Go into negative already.
Okay. So, this is speed, right?
Yeah.
Good. So what's velocity? Okay?
S is displacement, right?
S is displacement, right?
U is speed.
The U is initial velocity. V
Then
is the
speed is
final
what?
velocity.
Speed is what?
We talk about velocity here. We have no more speed
Oh, okay.
in physics. Okay? So velocity is the speed in a specific directions. Okay?
Mm-hmm.
And what is the direction of velocity? Remember, direction of velocity is direction of the motion. Direction of velocity is the direction of the motions, where you are heading exactly at that instant. So if an object traveling in here with 2 meters per second, and this is the speed they have, okay, 2 meters every 1 second. So when an object travel in 2 meters per second in this way, okay, we say the velocity equal to -2 per second. minus because you're heading this way, direction of motion. Okay? Don't worry about it, okay? They will force you to use it. Okay. If your object is being thrown in a parabolic, you know what's parabola?
Huh?
Or you know what's parabola?
What's that?
Parabola, para. You know what's the para?
No.
Okay,
How
para.
do you know Para Paradise?
Yes, that's why I'm asking para paradise. Para.
Bola. Hyperbola.
Para Paradise is dance one, eh?
Yeah, it stands one more. But they use the word para, right?
Yeah.
Para,
You
right?
go play, right?
Parabola. Okay. Whatever it is. Parabola. Okay, in Chinese, there's a name called 抛物线.
Huh?
抛物线. That means a path you will get when you throw something. 抛物, 抛东西. Okay. Throw anything. Okay. So this is why Chinese name spell everything was parabola. 抛物线. What's 抛物线?
Parabola.
Parabola. Okay. Symmetrical, left, right. You have a maximum or minimum that's called parabola. Okay.
I saw this in your video.
Is it? Yeah, because I teach the A level, the kinematic also, and they are more advanced. Okay. So, what I want to tell you is that in this one it's more than one dimension, so it's a bit more cheap. But what I want to tell you is that at this instant, what is the direction of velocity? Is this direction.
Yeah.
Okay, is where you're heading. Speed have no direction. Okay, what is the distance you have traveled? The arc length. What's the displacement? First point to that point concerned, draw a straight line, draw an arrow. This is the displacement.
Must
This is
draw
the
the
length of
arrow.
displacement. Arrow tells you directions. Okay, it's good to draw. Okay, direction of displacement is this way. So the direction of displacement is normally not the direction of the motion. Where you're heading is here. Yeah. So direction of motion follow the direction of velocity. Got it?
Why displacement is so straight?
Is got to be
Why,
straight.
why displacement is like that? I thought displacement is come back.
Not really. Displacement is first point, last point, draw the line back. Because in this world, right, it's not about come back is okay.
Then
Come back if the object keep moving in this manner.
if it
That means
this
keep go front back, right? Then you just get first point, last point. That means that this is the displacement I get, right?
huh?
Okay. I go here and I come back here. Okay. My displacement is this amount.
Yeah.
Yeah, and it got to be from here to the last instant, right? Okay. And when I go here and all the way I come back here, my displacement is this way, right?
Yeah. So it's from there to there.
Yeah. So this one is negative something, right?
Also the displacement is from the place where you go out to the place where you
Want to consider that
Reach.
displacement. Yeah.
the place that you go out to the place that you reach.
Yeah. Okay. So this is called the displacement of at this point. Okay. So this is the distance. How much? Okay. This is the displacement. How much? This direction. Velocity is the speed. How much in the direction of the motion where you're heading at the instant. And this is not just front back. So you cannot just use positive negative to indicate it. You will tell you how many what's a 0 to what bearing and these kind of things. How many degree above the horizontal, those kind of things. It's kind of complicated. A level, okay.
Okay.
A level, okay. Don't do O level. O level is just front back. But without this picture, you may not know. Okay. So this velocity. The third thing I'm going to tell you it is acceleration. Now accelerations is introduced here, okay, which is you have not learned last time. I accelerate, I decelerate. I accelerate, decelerate. You step the accelerator in the car. You play Daytona, you step the accelerator, it's supposed to go to front, otherwise it's going to get hey, it's not working, that kind of things.
You play Daytona, eh?
Daytona, of course, we play such a classical things, 3 years old to 80 years old must all play. Right? Okay. Accelerations. Okay? So what is accelerations? So what's acceleration?
Go in front.
Go in front. When you have a speed, 2 meters per second, are you going in front? Boom, 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 boom.
Yeah.
Are you accelerating?
No.
Haha, something is wrong. Accelerator, right?
Oh, accelerator, the speed must go up.
Yeah, so it is talk about change the speed.
Yeah.
Okay? So accelerations is defined as the change of speed.
Oh, this English, man. It's not even science.
Change the speed. Yeah, it's English. Come on, the whole world, everything is made of language, right? Even maths. This is English. Because you can speed it as x equal to 4 minus y, right? And you got to know in English what is the meaning of 4 minus y. And you need to know that in English y can be substituted by 2, the kind of things. And then you in English you don't know 4 minus 2 is, you don't know what's the meaning of 4 minus 2, then you know that x is equal to 2, it's still language. Okay. This is why Bible says that in the beginning, right, God made this world with words. Things are from words. We think that all this war and light and all these things are cement and whatsoever, right? But if right, a human being don't have a conceptual idea as what is the cement, we don't even have an idea on what we see. We call it light. We cannot call it light, right? We see a wall, we cannot call it wall, right? The wall to you doesn't exist, you know, because you just cannot understand what is a wall. Okay, so this is why we have the material there, but we need a rationale to know all these things. So this is actually words. Okay, all these things, okay, whatever it is. So acceleration is change in speed, or increase or decrease in speed, right? How to get increase or decrease? Use the final, subtract the initial. That's the change in speed, right?
Final subtract the initial.
Yeah.
Initial is what?
Say, initial, English initial. Initial, not initial D, initial speed.
The starting
The starting speed, normally at rest, okay, so but you can accelerate from.
The starting speed.
Wait. When you're moving with some slow speed already, and then step accelerated to a higher speed, okay? It's still accelerating, right?
Yeah.
Okay, good. So when I talk about accelerations, is depends on the change in speed, change in velocity.
What if all the line come out is 1 to 3, then after that 3 for quite a period of time, then 3 to 6?
Yeah, what if, right? Okay,
Yeah, then what's the acceleration?
So we need to learn about all the basic things you know what it is. One.
Huh?
Can you chop them to 3 parts and you want to learn one by one first? So fast you want to see about all those things.
Oh, okay.
Okay. Accelerations is something to do with the speed is being increased or decreased. Okay. Get the speed even faster, get the speed even slower, accelerations. How do you get the amount of speed increase? Use the final speed, subtract the initial speed, you get the increase in speed, right?
Okay.
So if you have the increase in speed, can I say acceleration is proportional to the speed difference? That means higher the speed difference, I call it higher acceleration. Make sense or not? In English. Higher increase in speed. That means I have made a higher acceleration. Make sense or don't make sense?
It makes sense.
Makes sense, right? Makes sense. So like you are the one, right? You say this makes sense. Okay? Good. Secondly, right, we talk about acceleration. How about with time? If I need to achieve this kind of, let's fix this amount of speed increase. When I step it takes 10 years to increase the speed. Another instant when you step it, 2 seconds you increase the speed already.
Yeah.
Same initial speed, same final speed that they increase. Do you want to call them the same amount of accelerations that they're experiencing?
Yeah.
So the one that increased very slowly also have the same amount of acceleration as the one that boom just increased like that.
Yeah.
Okay, I have a lorry from 0 kilometer per hour increase to 100. This is our standard, okay? Kilometer per hour, right? It takes 25 seconds. I have a Ferrari 0 to 100 in 5 seconds. The two of them have same accelerations. So you go to buy a lorry if you have the money for Ferrari. Can you see the difference?
But in the end, you're going to get the same speed.
Yeah, in the end, you're going to get the same speed. So do you want to call them the same acceleration or not?
Yeah, it's the same.
They have the same amount of acceleration, is it? They have the same amount of accelerating power, penalty.
No lah, not accelerating power lah.
So okay, let's talk about acceleration. Is actually the acceleration power you can talk about. Okay. So can we say that this is have higher acceleration than this?
No.
Why?
Cause this one faster, that one slower.
This one increase the speed faster. This one increases the speed slower. So that's why I say this is for higher accelerations. Yeah. Because once you talk about this, right, it is 100 minus 0 in 5 seconds. So in every seconds, right, it's 20 meters
Still got over 5 one meh?
per second. Okay? So that means it will increase this. No, if you do the divide by 5 seconds.
I didn't need to divide.
The weight, listen to me. Divide by 25 seconds, right? This one only have 4 meters per second per second. Okay? The idea is that if you do this, if you don't do this, you will have 100 minus 0, so you get 100 meters per second change. And you have change of 100 meters per second.
That's it's the same.
Okay, so this one is the same. Okay,
Yeah.
change speed rate. But if you divide the time, it is 20 meters per second increasing of a speed in every 1 second. But this one have 4 meters per second increase per 1 second. That means, right, I have the same amount of accelerations, right? But now if I fix the time, I say everybody give 5 seconds. Which one can go to a faster speed?
Of course, a Ferrari, yeah.
Yeah. So accelerations, right, got to define it this way. Okay, because it's not always this got to be fixed. Sometimes they fix the time. Okay,
If they never
and
fix time,
when you have both, right, it's up to you. Want to fix the same amount? If you talk about same amount, it means I tell you this one take lesser time. Okay, so Ferrari wins. On the other hand, right, if I divide by time, they give me same 10 seconds. I say Ferrari will achieve a faster speed also. So you have a consistency. Okay? You don't say a Ferrari same as lorry's accelerations. Okay? So inversely proportional to time. Okay? So we combine them, acceleration is equal to change in speed per unit time. Okay, so increase in speed per unit time, this is acceleration. Okay. So change in velocity per unit time, because they all got to be vector. Okay, better to say it is change in velocity or vector. Okay, so once you understand all these things, come with some definitions, you need to write them on paper.
I don't take A math, so you can't teach.
No, I can't, don't worry.
No, I know you can teach, but
No, you gotta learn also.
A-maths,
I will force you.
you're not taking A math, or you E4.
Is it?
So you teach E math and A math.
They take A-maths.
But I'm not learning E math.
Or you win, another guy will join it.
Let's balance E math and A math.
Can okay, because I think two more than one people is better sustaining. I can give you your longer
Science
time.
also take.
No, don't worry, okay, we'll do EMAS, AMAS, we'll try to, let's say have 1 hour AMAS, 1 hour EMAS, and then we do exercise. Make it 3 hours kind of things. Okay? Because we need more people to sustain a class like this. See about it, okay? 240 per 4 lessons, $60 per 1 lessons, half to him. So I left $30, 2 hours, $15, which is McDonald's price, right? Okay, my petrol come over, parking gone, okay. So so it does help us to do a better thing, okay, if more people can join. Okay?
Science you don't, right?
I don't know, I haven't asked him. See how.
Just try to help one another. Okay, I don't mind to give more hours and more resources for you. Now in terms of paper, you'll write something. Okay. Okay. So yeah, velocity. It will be an elegant way to say that it is a rate of change of displacement, which is in Amax differentiation. Okay, but that's the
differentiation.
yeah, but that is the wording. Okay, you want to tell them what's velocity. Velocity is defined as the rate of change.
Right, huh?
This one need right?
No need, it's in the textbook. Okay,
Oh.
of
Own.
displacement.
Rate of change of displacement.
Okay,
Rate.
the rate of change. Anytime you have a DDT, it is rate of change. Okay, we respect the time, but we don't mention it means respect the time. Okay, rate of change. Okay, acceleration is defined as the rate of change of velocity.
The rate of change of
The
velocity.
rate of change of
Wow.
velocity. Okay,
English is ugly spell.
don't worry. Okay, in the Amax time you come back again. Okay, just to tell yourself you got something like that.
Rate of change.
That's the advantage of studying A-maths.
Yeah.
velocity.
Okay. Okay, so come to the main thing what you need to do in this chapter. The first thing is you need to get all your variable crystal clear. Okay? Crystal clear. Okay, going to be very clear. Okay, what is speed? What is distance? What is displacement? What is velocity? What's acceleration? Okay, and what's time? Come on. Okay, the time is the time about the initials to the finals. Okay, so we need to learn in two ways. First one is by equations. Second one is by graph. Okay, they will ask questions either by equation or by graph. Okay, by equations, right, you will have it depends on the acceleration you have. If you don't have acceleration equals 0. Okay. What's mean acceleration is 0 means actually no change in speed. Okay. If in your fragment, the fragment that you want to consider has no change in speed or acceleration equals 0, you only have the ultimate formula of a primary school formula of speed or velocity equal to distance or displacement over time.
Okay.
This is very cheap, okay, so remember it. Okay?
Distance.
So, yeah. So, the second thing is that, what if the acceleration is not 0? Okay, if acceleration is not equal to 0, you have two choices. Okay, first choice is that your acceleration is equal to some number, which is a constant. Okay, that means, for example, acceleration in this whole thing is 5 meters per second squared.
I totally don't understand
Fixed.
constant.
Constant means a fixed number.
I know it's a fixed number.
Okay, make it English. Okay, when acceleration is a fixed number. Okay, now when
Like
acceleration equals 0, when acceleration equals a non-zero fixed number, like acceleration equals 3,
You can anyhow put one, man.
for example, one fixed number, what I'm talking about.
Uh-huh.
But it can be any fixed number. That means the number is not keep changing.
But how you know what number?
The question gonna tell you.
Oh, okay.
Yeah. Okay. One jump example. Okay. This is concept. Okay.
Okay.
Acceleration equals 0, you have this. But acceleration is a specific number, and this number is not 0. That means it can be any number so long as it's not 0 and this number don't change.
It's a constant.
You have 5 formulas. You have 4
Huh?
formulas. You have 4 formulas. Yeah, you have 4 formulas. Okay. Wow, cheap man, tell you the formula is very cheap. Okay, look here. The first formula is called acceleration equal to final speed minus initial speed over time. These are definitions you learn, right? What is acceleration? You will remember it, right? Okay, this one copy down, right? Because textbook may not teach you.
Initial speed minus final speed.
No, final minus initial. Okay.
Huh?
Final minus
Final.
initial. Increase in speed, right? Okay. So final minus initial over time, okay?
What is
That's
decrease
definition
in
of
speed?
acceleration. Okay, tired.
Deceleration.
Deceleration is a negative acceleration. Don't think it as another formula. Okay. Okay, so acceleration equal to 3 meters per second square. It means deceleration equal to minus 3 meters per second square. Okay.
So I do the acceleration, then I put a minus in front.
Yeah, that's a deceleration. So, but on the other hand, right? You say accelerating, or the other way around, you say it's a decelerating how much?
Okay.
Okay. So those things you do questions you clarify. Okay. The third thing is that what if acceleration is not a constant, so it is a fluctuating function of time. That means this instant is 2, the next instant is increased to 3, and the next instant increased to 4, and then drop back to 3, and then go to 0, and keep changing.
Okay.
Okay, this is A max. Okay. So not in physics. So I'm not going to teach you now.
Okay.
Okay, so that means you end up here. Okay, no more. Okay, so this is the first equation. Okay, second equation is called very cheap, also very cheap. Okay, average speed. Now when you put the bracket means average. Okay, this kind of bracket. Some people put a bar on top. Okay, but this is mod max. Okay,
V is
the
what?
two bracket
V
velocity.
is what? Velocity.
Yeah, okay, or speed. Okay,
The
average
bracket
velocity.
is what, ah?
Bracket means average.
Okay.
Okay.
Wow, totally cannot remember this thing.
Write down. Average velocity.
I hate this sort of thing.
Okay, average speed, okay, or average velocity, okay, because in your syllabus is all front and back.
This one is it inside the what booklet again? Formula booklet.
No. No, this one you need to remember. Can you remember by English, you know what is average speed?
No.
Average
I
the
can't
speed.
write what? Right, what? Average speed.
Yeah, you can write average speed. Or what's the problem?
I must write like that what?
No. You can write average speed. Who says that you must give me the rationale? I can write very clumsy English. It's the average speed. I don't use equal. I use the English equals and 2.
Can meh?
Why cannot?
Oh.
Do you ever see some questions called sodium hydroxide is reacting with hydrochloric acid, give you 1 mole of water and 1 mole of salt of sodium chloride?
No.
They can write it this way, what? Eh? But you're just playing around yourself only, what? Waste your time. Okay? They cannot say you're wrong. Did they put a cross there? I don't think so.
If they put a cross out.
Ask him what's wrong. Okay?
You don't know also, they never give you back.
They don't know. You better go back and study. Okay? I'm playing the MOE, those things, right? It's always like the average speed, okay, total distance, okay, so displacement or distance over time, very cheap. Right, can I? Okay. But, okay, if it is average of speed, I have initial speed, I have final speed, and it's increasing in a constant way. Okay?
Speed over.
I ask you some IQ test, okay? Hello, follow me, can you look up me, please?
Continue, say, yeah.
If I start from my speed with 0 meter per second, that means I'm not moving, until I increase the speed of 10 meter per second. Okay, so I have 0 to 1 to 3, 4, 5, 6, 7, 8, 9, 10 meter per second, right? So what is the average value?
5.
Why?
Because it's in the middle.
You're right.
It's like a mean or a medium or
That's the formula you need to know, okay? Do you need to know this formula? No, know this formula. Okay, this is what you know.
That one don't need to know.
Oh, you need to know also, but this one by common sense, I think you will know. Okay, when they ask you find a average speed, you will tell them this, right? Wait, these two formulas, do you need to remember anything? They're common sense, right?
No.
You know what's acceleration, you know this, right?
For me, it's not.
You know what's the average velocity, you know how to get average by yourself. You got this, right? Any new thing, alien thing you learn so far? Any alien thing you will memorize? I don't think so. Anytime you can derive yourself. Come on, average speed, distance over time, what's the problem? Total distance over time taken, right? Midpoint of the initial final, that's what you derive from. So you can remember this. Recall this anytime, don't take it as alien memory, okay? Because the alien memory comes here, okay? Now this one is the differential accelerations. Either you don't know acceleration or you know acceleration. It's a change in speed, increase in speed by how much? Final minus initial, divided by time taken for your change, okay? So, the thing you need to remember is this.
The time must write like that one fish then.
No, that is T one.
Why like that one, man?
You can write it any way you want.
Okay.
Can you copy down these two? And you got to eat it.
Yeah.
Yeah, so this two you need to use your heart memory, okay?
Speed equals to what?
Not speed, displacement.
Oh, displacement.
S equal to ut plus half at squared.
All the S is displacement
Yes.
Oh.
So
then up there the S
speed
also
is displacement or distance over time, right? Average speed.
U is
Initial speed.
initial speed. V is
Final
speed.
velocity. Yeah.
Final velocity. A acceleration, T time.
Speed equals to what?
Ut plus half at squared. Easy to
No,
remember.
displacement equals to U is what?
Hey, can you define this 5 symbol first? We're still going to use a lot of these kind of symbol. Every time you want to use a word, right? Define it on top.
SUVA.
Each
S
one
equals to displacement.
U
And
equals
U equals to I don't know what.
Initial speed, initial velocity, okay?
Initial
Velocity.
speed.
Velocity, use velocity.
Velocity. V equals to velocity.
final velocity.
V
Accelerations.
equals to final velocity.
Yeah.
Must be final.
Must be final, yes.
A equals to acceleration. T equals to time. Okay. U T plus half A T square. V square to U square. Okay.
Now, so we have how many equations? 4, right?
Yeah.
How many variables? 5, right?
Yeah.
Okay. So is it sufficient for all cases?
No.
Yes.
Huh?
It's sufficient.
Okay.
Because each equation inside have 4 variables. So all you need is 4 equations. You have the fifth situation, use simultaneous equation. 2 equations, 2 unknown, solve it. Okay? That means this is a minimum amount you need to remember. So analyze a bit what's so special and what's the difference between all these equations. Okay?
One calculate velocity,
No.
one calculate.
Look at here. This one have no s.
Ooh. No.
This one have no
T. A.
no no a.
A.
This one
No,
has
ah. This one have no V.
good.
Then the last one have no T. Not.
So what situation is the prohibited one that this 4 cannot cover? No what? Which you cannot use the equation to solve it.
SAVT, SAVT,
Yeah, no U. Okay. Normally the question will not give you no U. Okay. If they give you no U, no issue. Choose any 2 equations, simultaneous equation. Make U as an unknown, make your answer as a second unknown, 2 equation, 2 unknown, go to solve it. Okay. If they're so mean, okay, normally it won't. Okay. So once you see the number given to you without A, you use this. They give you everything no V, you use this. Okay. So so if something I jump, okay, this is the floor.
the head will crush.
What's the final speed? If it's 10 meter, accelerations downward is, let's say, 10 meter per second square downward. And then of course if jump in this way, then the initial speed is equal to 0. What's the final speed here?
0.
Yeah, 0 I will have. So by the time I reach the floor, I suddenly stop momentarily.
Yeah, what you reach the floor,
then-
you will stop what?
And then you reach the top the time you're fast or slow? Tell me.
Huh?
If reach the top the time I can just stop it, right? That means I'm a Superman, that I can land. I jump and I land back. Okay? Okay, anyway, okay, I think I will die. The reason is because do I have fast speed?
Yes.
I need to have a fast speed impact the floor, right? You don't care about now all this kind of kinematic, right? There's no force. We don't talk about impact. That means it's about a smooth motions. When after you smash the ground, become whatever it is, okay, that's another instant. So the kinematic is right before you hit the ground. Okay, so what's the final speed? Do you find it? Now, if I want to find V,
I really know how to.
listen. If I want to find this answer, must this answer be in my equation?
No.
If I want to find X, must my X be in the equation?
Yes.
Yes. Okay.
Oh, okay.
Yes, right. Okay. Not no. Okay. So
No,
my
say-
so my V must be in the equation.
Yeah, okay.
So I have U,
Mhm.
I have A,
Mhm.
I have a distance to travel, so which I have a S.
Mhm.
Okay, and then I need a V to be in the equations. So what is the thing that you don't have? The T.
Yeah.
So no T. So use this. So what do you have? V square equal to U square, which is 0 square, plus 2AX, 2 times 10 times 10.
Why 10 times? Oh, that is.
Displacement.
A is 10, displacement is 10 also. Right? 10 meter per second square, and it is 10 meter.
V square equals to 200.
Yep, so V equals square root of 200.
V
You can
equals
answer.
to
You know the speed when it's
V equals to blah blah blah.
smash on the ground. Okay? Okay, so that's the 4 formulas, and that's all you need in the calculations. Okay. Okay, so the last one
Sort of
graph.
easy lah.
is easy one.
But only the
Don't be lazy lah. Okay, at least you have something to remember. Okay. Otherwise, nothing to learn, then every chapter nothing to learn, then waste time.
good what, don't need to go to school.
What's so good about not to go to school? Huh?
Everybody have free life.
Yeah, so what? What's so
Don't care about
good?
economics, so many
So
crap
what's
stuff.
so good about in 10 years time you also don't have to care about life and you just keep spending your time for nothing, no achievement at all, and you are no different from the others.
Can be a monk.
Be a monk also want to be a high monk or that kind of things.
No.
Just be a nobody monk, nobody care about you're a monk, then forever is it? If everything come out with nothing, then why in the beginning there is so many things?
I don't know.
I don't know. Simply, people says that a lot of people says that living is meaningless. I see some friends right recently say, oh, living is meaningless because anyway you die, or that kind of things. Right? You see a lot of Indians say this one. Oh, okay. So I just ask him, so if you didn't eat for let's say 4 days, you get very hungry. I got food in front of you. Will you eat? Don't eat. You anyway die what? Then I tell you, okay, I'm not joking with you. I'm just saying that, but your body tells you you don't want to die, right? So why you don't want to die? Maybe something that you seek about for your life, that kind of things. There must be something. Otherwise, why don't you just die like that? Okay, whatever. Okay, so that kind of thing.
Ow.
Okay, where am I? Okay, graph. In the graph, where we have 2 graphs, okay, interested. Okay, mainly they are
Two only ah.
Yes, 2 only.
Good.
Displacement time graph, and they have a velocity time graph. Okay. Of course, okay, we talk about we have distance time graph and speed time graph. Okay, now learn the basic first.
Soon is 4 lah.
Yeah, but I just to know some feature first, okay? Okay, if you have a graph like displacement, it's okay like that, right? Okay. This is not okay to be like that, right? It got to be. Now, so if the displacement in this way, what is distance? In the equivalent way, right? Is that the idea is that the first portions will still be the same. Okay? Increases displacement, you increase the distance that you travel. The idea when displacement come back here means that I actually move backward. When I move backward,
The distance goes up.
the distance keep going. So from here to here, right, is actually like that.
Then you must
Now it's like the z in this way, right? Don't bite the z in that way. Flip it. Okay. But from here, right, so long as keep increasing, right, they are the same again. So the only idea how to
so how you draw ah?
yes, this is exactly I'm teaching you how you draw. Okay, if you have this, want to flip to this, okay, all you need to flip is that you only need to flip the downward component,
Yeah, I know.
and the upward component must copy. So you see the first one must copy, the last one must copy also. Okay, so how do you do this? Just do a up down flip. Okay, and then the first point still going to join the first point, end point was going to join end point. So if you want to join end point here, flip in this way.
Okay.
So instead of coming down this way, you're going up in that way.
You draw on the same graph one meh?
So you get here.
But you draw on the same graph meh?
Depends on questions. They may want.
If it's different then you must measure.
No need now. Okay, whatever it is. Okay, if they need everything, then you do everything lah. Okay, how do I know what they want? Okay, but anyway, I will teach you here. Okay, how to translate a displacement to this distance graph. Okay, if you have a velocity graph, velocity and speed, they are all okay with this.
They'll never give you displacement and velocity, right?
Don't waste time.
I mean steering wheel or not lah.
How do I know? Okay. They can give you anything they want actually.
Then how you transfer displacement and velocity?
Use the concept that you've learned here. Everything that they ask you to do, you need to have a concept that you learn. And with the concept, they can play anything they want to. There's no limitation for that. Velocity and speed graph in this case is the same because well, this one itself is okay for speed. Speed can come back. Can? So no issue. So when can I make a velocity and speed graph difference?
When velocity go below 0.
Yes. Okay. So if I have this, it will be different. So how to draw the speed graph? Okay. Now drawing the speed graph here is to place an absolute value in the velocity here. Absolute value will learn in max. Okay. So first portion is the same, last portion is the same. This portion do a flip.
Something like displacement and distance.
No. This one, the flip, right, is in the mid-air.
I know. I mean, 反正就是 flip lah.
Wait. The flip here is anything below here. Okay? And it is on x-axis. The flip here is any time they drop down. And secondly, look at this. You see sharp corner here.
Yeah.
You see sharp corner here.
Yeah.
You can never have anything sharp here.
Yeah.
Okay? It will be different. Be very careful, okay? This is
I know, I mean, this is the same flip.
okay, whatever. Anyway, this is not what I'll teach, okay? Good, okay? Then we focus on the velocity time and speed time graph. So do you know what's the mean of gradient or curve?
Gradient is that one.
y2 minus y1 over x2 minus x1, those things?
Yes.
Okay.
But you want to say again because I forgot.
Displacement of 2 points is just
Set 1 got teach before.
so you know what is the meaning of gradient or
I know
curve?
the meaning but I don't know how to calculate.
Don't you have to know how to calculate? Do you know what is grade do you know what is tangent to a curve?
I don't know.
A curve like that. The tangent at this point, you know this is line.
No, this one.
Okay, now when you have a curve, okay, when you have a line, there's only three things can happen. It cuts. However it cuts, okay? Or it don't cut.
Okay.
The third one, and if it cut, right, okay, normally we have more than 1 point. Okay. If you only cut 1 point vertically, it's called normal.
The normal, yeah, I know.
Yeah.
Normal, I know.
If it is perpendicular to normal but actually cut 1 point here, it's called a tangent.
Oh, this is a tangent.
Okay. So tangent and normal is guaranteed at least at that instant only cut at 1 point. Okay. So we will not cut at any closed surface will cut more than 1 point. But we focus on tangent here. Okay. I want to tell you that if you have a displacement, the gradient at any instance, the gradient value will be the velocity
With the velocity.
at the instant. On the distance time graph, at any instance, the tangents, the gradient, will be speed.
Okay. So velocity tangent would be
Do not confuse, it's displacement time, the gradient is velocity. So,
gradient is m.
yeah,
Can you use g?
no,
Why?
sorry, gradient is m, yeah,
Not use g.
gradient is m. Use g, y g, y m, m, y m. Because max we use m as gradient.
Oh,
Yeah.
really? I don't remember it.
Okay, you have this speed, you have this speed. Which speed is higher? The one at the left or the one at the right? Which instant have a higher speed?
Left one.
Yep, good. Okay. The velocity positive, negative. For this,
For this negative.
negative, good. Okay.
But why
Because the gradient is negative. Because the gradient is negative. The gradient of the tangent is negative. Positive, negative, right? 0. Undefined.
Oh, positive,
Max.
negative, 0 undefined.
Max, right? Okay. If a graph makes sense, you got to make sense always. In all cases. So that's about displacement time graph. Okay.
Okay.
Well, for okay. So tell me, where is the point that the graph? Where's the point that the car is stopping?
The car is stopping is there.
How many stops does it make?
For the car?
Yeah, for the whole journey until like that, like that, like that, until it's smooth again. So how many stops do they have in the whole journey?
3.
Which 3?
One is the curve on top.
Yeah.
Yep.
Good.
Another one is below.
Here.
Yes.
Good.
Another one is there.
Here.
No, in front.
Here.
No.
Where?
The line, the starting of the last line.
Here.
Yeah.
Okay. Good. Is this rest?
No. Is this what?
Is this resting also?
Yeah.
Okay. Good. Okay. Is this rest?
No.
The gradient is horizontal. The gradient tells you
Or it is a rest.
it is a rest. Okay. The gradient is 0, you see, or this point. Gradient is a speed. Speed goes 0 means it's resting.
Okay.
Okay, so you must know how to interpret those things you learn. A velocity time graph. Okay. Now you've got 2 things to learn here. The gradient.
Why must it be there? Cannot be any point on the.
It can be any point. Why not? Okay, you just draw the correct tangent. The gradient of the tangent at the point.
But must be like that, man. Why cannot like that? Or like
You
that?
cannot cut. Tangent means that 1 point.
Oh.
If anything that you want to be like that, you cut 2 points already. It's not tangent anymore.
But now you also cut 2 points, what?
I draw not nicely, lor. Okay, supposed to draw very nicely that you only cut 1 point.
Okay.
Okay, it's got to be that tangent, okay?
But you draw like that is 1 point, you extend the line is 2 points.
Oh, yeah. 1 point at that localized region. You can cut another place. For example, if my curve like that, right, this tangent is tangent at this point. But you can cut another point. No issue. I'm talking about at this instance, I cut 1 point. Follow the curvature at that 1 point.
But
Yeah. So this is why I always try to draw in some easily illustrated places. Okay? So honestly, does it mean the tangent cannot cut the curve again? No, it can cut, but not at that spot, or not near that spot. Got to be somewhere else.
But your this one also not near what?
Which one?
That one is
Yeah,
cut
this is
two.
quite far away already, right? Cut another point. So at this point, at least there's only cut 1 point. Okay, you don't do a cut 2 point. It's a core. Okay. Okay, so the gradient in the velocity time graph is acceleration. Okay. And the area in the graph is the distance you travel, or displacement you travel. When the area is negative, means that this is the area that you move backward.
Okay.
So if you do this area, subtract away this area, it will be the displacement. If you use this area, add this area, it will be the total distance travel.
Okay.
Okay? So cut all the crabs.
But
Okay?
the area, how to get the area?
Normally they will give you regular shapes. Okay?
Oh.
Then you cut them in trapezium, rectangle, triangle,
Then you
whatsoever.
calculate lah.
If the worst things like that, they will give you the boxes, then you count the boxes.
Okay.
Then you time the boxes, agglerations, okay, give some estimate.
Ag-
You know the agglerations, right? Okay, chimology, those things, right? Okay?
Okay.
Area, so what do you need to focus on? What do you need to focus on? in the displacement time graph, what's the specialty here? The gradient is?
Velocity.
Velocity is the gradient, right?
Ah.
Okay. Velocity time graph, two things. What are the two things?
Gradient equals the acceleration.
Good.
And then the distance minus the
No. Area under graph is a
displacement.
displacement. Good. Okay. And positive, negative area. That means positive distance,
What if it's positive, positive?
positive, positive. That means the distance you just add them up. Displacement you still add them up. The same thing.
But if positive, positive, then add the displacement. If positive, negative, then minus.
Yeah. Minus you get the correct displacement. And displacement can be negative if the negative area is greater than the positive area. Got it?
Good.
Okay, so to link up two graphs,
Why displacement can be negative?
one displacement can be negative.
Oh, okay, yeah.
That one means negative, forward means positive. Okay. You're falling asleep. Don't know why I don't want to fall asleep. Okay, keep going here. Let's have an example. Okay, let's have an example. If you have an object, okay, dropping, okay, let's say okay, same issue here, okay. If I have let's say but I jump a bit taller building, okay, let's say 20 meter. Okay, 20 meter I don't think I will have any issue. 20 meter will die or not?
Die.
20 meter
It's 6 story, you know.
6 times 3.
6 story is
6
die.
story and still die, okay.
7, 8 story already. HDB flat.
Okay, whatever. Okay, so I will just hook out here. So initially, I'm not going upward or upward. Okay, so initial speed is 0. Okay, and let's say acceleration is due to gravity. Okay, in the dynamic you would know. If my acceleration F equal to ma, ma, right? The only force is the mg. So mg will equal to ma. Therefore, in that case, your acceleration is equal to g. Okay, but okay, there's no, in this case, acceleration is equal to 9.1 or equal to 10 meter per second square.
Then how to calculate? Must calculate.
Am I in the calculation chapter here?
No.
No, I'm teaching you on graph, right?
Okay.
It's a whiteboard will calculate. Okay. So, what's the speed here? Now, this question we've done by using calculations, right? Okay. So I'll tell you, graphical method also can. So if all this piece of information, can I draw them all on the graph? Okay. First thing is that I can draw on velocity time graph. It's always the velocity time graph will give you all the answer. Okay, you can try to play around with the displacement time graph, no harm. And let's play with displacement time graph first. Displacement time graph. Okay. So displacement time graph, you will tell yourself where do you take as a starting point and which direction you take as a positive. These two things you must say. Okay? Because the motion is dropping down. If I take the initial point and it's at here, okay, if down is negative, then my graph will go negative. Okay, but if I take downward is positive, then the displacement will be positive. So it's up to you to take. Okay, so I will take downward as positive, so it makes more sense. Downward as positive. Okay, so I know at this instant I'm at 0 displacement. Okay, at this instant I have a displacement of 20 meters.
You feeling cold?
So from here to here, right? There are many ways you can draw it. First is this. Second is this. Third is this. So this way, or this way.
Oh, that's a quantum physics.
No, quantum physics. It's not about this.
Yeah.
I know quantum physics.
Next.
So which one?
The middle one.
The middle one, gradient of this graph is what? Tell yourself, what's the gradient of this graph? Definition of gradient, just now we learned. Displacement time graph gradient is what?
Velocity.
Velocity. So did my gradient change?
No.
So that means you never increase or decrease your velocity, right?
Yeah.
That means you never increase or decrease your speed, right?
Yeah.
So am I dropping into constant speed? Or I'm getting faster and faster? Which one?
Faster and faster.
So can it be center line?
No.
Cannot be, right?
Oh, so it's the bottom one.
Why not the above one?
Because the above one is faster and slower.
You're right. So that's why this is the graph. Okay? Good. Okay. But can you calculate anything here? No, you don't know how much you curved, right? Okay. So normally this graph cannot help you in calculations. But they can ask you to draw this graph. You can sketch them. By how do you draw a graph? Okay, in physics, always do this. Always first plot all the critical points first. Okay, then you think about how they should change. Tell you so that what's the velocity and such. Okay, now VT graph. Okay, this is easier. Initial speed is what?
0.
0. Okay. Should I have some final speed? I think that one is positive. So I have a positive high speed when I reach the ground. Make sense? Okay. So I want to join up. The gradient of this graph is so which one?
Below what now?
Reason?
Velocity is going up.
The gradient of this graph is what?
So gradient now.
This is why they keep asking you on the 3 things. Gradient of this graph is what? Gradient of that graph is what? And the graph of this what?
Acceleration.
So accelerations, did acceleration change?
Yeah.
Change from what to what?
0 to something.
I thought acceleration equal to 10.
Oh, I never see. 0 to 10 lah. Oh, 10 meter per second. Is it?
Wait. Okay. The speed from 0, right? Speed, right? I have some speed, right? The speed increasing, right?
Is increasing 10 meter per second.
Yeah. So the increased amount is it a constant or to keep changing?
Changing.
From 10 meter per second become how much?
Oh, it's constant.
Constant, right? So the gradient of this graph got to be
Constant.
constant. So which is the line?
The middle one.
Good. Can? So how do I draw this piece of information?
20 meter length.
How do I draw this in this
No
graph
idea.
here? What is equal to 20?
Distance traveled.
So what of this graph is 20?
The line there.
The what line?
The middle line there.
The middle line is equal to 20, is it? Line 20 or gradient or the area or what?
Area.
Area, right? Good, welcome back. So this area got to equal to
20.
20. It's not good enough. You still have need one more piece of information. Which is 10. The gradient equal to 10. Got it?
Yep.
Okay.
Yep.
So if this is V, this is V, right? Hello. Okay, don't write.
Okay, next.
Is this if this is V, right? How about this?
How about what?
This.
This
This
equals
T.
to
What? Oh, what? Say again.
Is this a T? The time taken from between this one? This distance is called, or this length is called the time between this one, right?
Yeah.
This length is called the V minus 0, so it's the V, right? So how to form an equation with the 20 with V and T? Primary school stuff,
Oh.
geometry. What do you have?
Wow.
Yep.
Just DTS
I don't think too cheap in primary school, you don't learn all those things. Okay. 10 equal to half time form equation. Area of triangle is equal to come on, don't waste your time.
Area of triangle.
Oh no, what 10?
It's not.
Sorry, I misled you. Eh?
And it's not half, right?
Half what?
Half
What
time.
formula?
Half base times height.
Yeah, so what is that?
Half time lah.
T.
Half t times v. I thought find what?
Yeah, very
Find
simple.
the
One.
area. I thought you said go and find.
Okay, gradient.
Oh, that one I can remember. That one I can remember. Really?
You know what's a gradient in Chinese?
斜坡度.
You're right, 斜率. Okay, you know what's a gradient in British Cambridge? Cambridge we normally call it gradient.
We call it
Only
slant
Singapore
height.
call it gradient.
We call
Cambridge
it
we have very
slant height.
very beautiful word called slope.
Slope.
S-L-O-P-E. It spells what it means. The slope of the curve. The slope is equal to this and that. They use slope. We Hong Kong use slope also.
Is it?
Yes, a lot of countries use slope. Except
Malaysia
this.
use radians.
Yeah, Malaysian elegant, you know, elegant, okay? Elegant gradient. Okay? Well, how's a gradient? That's cheap. After they learn the gradient, everything gradient already, okay? But have a more
Should use slope lah. Actually, gradient very blur, you know.
斜坡啦。
You gradient, you velocity, you displacement. What?
yeah, okay?
Cannot use simple English, man.
Yes, that's what. This what. Because they don't use it, this is why I'm here, okay? This is why I earn my money. Because they don't speak it.
Why cannot
That's
use
that.
simple English?
Hello, okay, so slope, right?
Slope.
Slope means something is more slanted, you get higher slope, higher gradient, okay? Something is more gentle, you get lesser amount, that kind of thing. So, how 斜, okay, how slopey it is depends on the ratio
Yeah.
of what to what.
High.
So what's the meridian?
V over T.
Right. You see, once I tell you the word is called slope, right? You don't have to
Why not
memorize
T
what it is.
over V? Oh, cause V is on top.
Yeah, you want to be proportional to this and inversely proportional to this, right? When this is longer, you want it to be higher. When this is longer, you want it to be smaller. So put it in the correct place. Okay, do equation 2 unknown.
If it's the opposite side,
Opposite side.
Like that lah.
Like that, is it?
No, like that. How can it be like that lah?
What?
It's still the same. It's still the same.
Still same?
But you take the V that side. That side. The V is that side. That side.
This side? Or this side? Then?
Yeah.
Same.
It's the same one.
Same.
But you 这样子看的话，
Not really, not really. The slope things come before max. The ancient time and slope is nothing to do with max. It's all about a really slope. I'm going to build a building, roll it up, but that's a slope. So normally it's really come from a real life geometrical slope. So how do they tell the slope is how which is more? Okay, they have a lot of problem at the time. Why? Because they have a slope like that. And then they have another slope, right? Like that. Okay? The point is if they just use this height, right? This height is higher than this height. But this is more slope than this.
Yeah.
So the height itself cannot do. But anyway, for the same distance, right? They have a higher height, right? They say this is more slopey. Okay, for the same height but with a shortest distance, okay, we say it is more slopey also. So then they need a ratio. Okay, so normally we look in this way because it's really a slope going up. People can measure from the ground as this, and from the floor it is this. Okay, so this is why we don't take it at the left hand side, be weird. Okay, I'm not saying you're wrong, but that's where it comes from. Egyptian. Okay. Okay, so what's the answer? How do we get the answer? Okay, simultaneous equation actually just multiply with 2. Look here, okay, I know you know how to do. Let's do a special one. When you multiply them together, left hand side have 200.
Displacement gradient is what?
Displacement time graph.
Oh, velocity.
Yeah. Do you know there's a trick? The trick here. Okay. Now if this look here. Hello. Don't waste my time. Okay. Don't waste your time also.
Okay.
If this displacement, right, is in meter, okay, this is in second.
Mm-hmm.
Gradient is always y divided by x. So gradient, it will have the unit of meter per second. So you know its speed.
Mm-hmm.
Okay. If the velocity, right, is meter per second, is second. So the slope, right, is meter per second divided by second. So meter per second square. So it is accelerations. Got it? And when the graph is a multiplication, so meter per second times second you get back meter. So this is why it's distance. There's a way.
Continue.
There's a way you don't have to remember. Okay?
I want to feel this chapter.
Yeah, because you waste a lot of time on OL questions.
But 我不会吗
No, it's always like that. Psychologists tells us, right, everybody can only focus for 20 minutes. Average person. So if you use the 20 minutes for a lot of nonsense, after that you have no more strength for anything. Okay? Well, this is how I earn my money also anyway. Okay? So you time all these things, okay, you got half times t times v over t. Okay, t cancel. You got v squared over 2 is 200 here. So v squared equal to 400 thanks. So therefore v equal to 200.
V square equals to 1 times. Okay. That's all.
Yeah, so this is why you know this speed is equal to 20. Okay? And then if you want to find a time, substitute the t inside here, 20 here, so v equal to 10 times 20. So equal to 200 seconds. So wrong. Substitute here, wrong. 10 equal to 20 over t, so t equal to 0.5 seconds. So 0.5 seconds drop to the floor. Okay? That's why I tell you that a VT graph can solve all cases also, if you don't want to bother about remembering the 4 formulas. Okay?
This is even more waste time than the 4 formulas.
Yes, this is why the 4 formula is worth to remember. Okay? Either you spend a long time remembering, in the question comes in, the variables you just list it out, okay, just use the right formula and just plug in, get a calculator answer. Otherwise you will keep thinking about all the
Unless he say
triangle,
use the graph method lah.
and then the not yeah. Otherwise it's okay. Hence or otherwise, it's up to you. Okay. So up to you to use which method, but to me it's like the formula method, right? You cannot escape. Come to A level, you still got to use it. Go to poly, you also have to use it.
Amex also got this, right?
Amex is on differentiation already. You won't do things with constant. We still do things with constants with accelerations.
Mr. Cheng say
I don't think so.
months. Not the 1 whole year. What else? What?
Okay, yeah. Okay, so come to some more things. Okay. Now, if this time right, I'm going to throw this object up with this is just like listen, okay, with 10 meters per second. This 10 is annoying. Okay, let's have a 5 meters per second. Okay, this object of course will go up and down. Okay, hit this. Okay, so let's say it's 20 meters.
Go up and not come down.
Okay. How will the graph look like? VT graph. How will it look like? Okay, accelerations is downward 10. How will the graph look like? Give me some points.
Go down then go up.
Starting at where?
0.
If you start at 0, this is a velocity time graph, right?
Ah.
If the y value is 0, means that it is velocity 0, right? Velocity 0 means the speed goes 0, right?
Yeah.
But I say initially it's 5 meters per second up, right?
So you start from 5.
Start from 5, good. Positive, negative.
Negative.
Up to you. Okay, you can take positive, negative.
Negative.
You say negative 5, right? That means you're saying where's the positive?
Upstairs.
You're taking positive, upward positive, or downward positive. You will say it is -5. I'm sorry, you're saying -5, right? You say -5, right?
Yeah.
You say -5 is which one you're taking positive? Why is it -5? I'm not saying you're wrong, eh? You gotta tell me your rationale. I want to see what you're thinking.
Go up what?
Go up means what?
Because when you come down, if you come down it's positive, then you go up should be.
That means you
negative,
take down is positive, right?
Yeah.
Okay, fine. No problem. I'm not saying you're wrong, eh? But you tell me if you take down positive, yes, this is -5.
Yeah.
Okay, good. Then stick to what you take and see what will happen. Okay, you will still be correct, but it will be a lot more complicated only. What's the next point?
The next point is down.
Here.
Oh, that one's up.
Here.
Here is in the middle
In the middle, what value?
of positive and negative.
Positive and negative. 0, is it? Here.
Yeah.
Good. So next one.
Next
Where
one.
do you want to consider next one?
Down.
Here.
Yeah.
Okay. So what do you have?
Up.
Up.
Yeah.
Okay. Good. Okay. Same height. Is it 5? 5?
No.
No.
It's 20.
Oh, it may not be 20. Okay. This the number change already.
Oh.
Okay. Okay. Tell me. This instant. Is it 5?
Yep. It's 5.
Good. Conservation of energy. Okay. The kinetic energy you have here, beyond potential energy here, chemical kinetic energy. So these two are the same kinetic energy. Or parabola energy the same situation. Okay. So this is 5. You have an extra point here. Okay. So 1, 2, 3, 4. You have tap, 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 tap. So how do you want to join them?
Curve, then go up, then curve up.
Make sense or not?
Yeah.
Straight line.
Yeah, you straight line, yeah lah.
Why? Why straight line?
Causes velocity. M equals to acceleration. 10 meter per second.
Heat change?
No,
No, right?
it's a constant.
It's constant. This one is a straight line.
Oh yeah.
Got it?
Okay.
So how about displacement time graph?
But I thought you said it's why complicated?
Oh, it's easier to draw it this way. Doesn't matter.
Really man?
Yes. Who cares? Anyway.
But
Hello, I'm not saying you're wrong, okay, you're correct, okay, so.
if you draw like that,
I
the
don't waste
slope
time,
how
don't
you
waste time
score?
here. This one? Displacement time graph?
Displacement. Yeah, I think start from 0 lah.
Okay, good.
Go up.
Go up,
Nah. Go down.
go down,
Yeah, go down. Then go up.
go up. Do I reach back? Same point?
To same point, yeah. Then after go up again.
Yeah.
Yeah.
Good. Okay.
Okay.
Straight line?
No, not straight line.
How?
Curve.
I think this is the only way to curve, right?
Yeah.
Okay. Displacement time graph. No issue, right? Good.
But I also can draw it the other way, right?
Draw it another way. Can, of course. Normally we draw it another way. You always keep taking
Really
the
meh?
other way.
But like that 好像比较容易 eh.
Not really. We always take the we always take the initial direction as positive. When I go up, we take up positive. Because when, like that, right? Look at here. The displacement time graph, right? Be like that.
And then my,
Easy?
my thinking weird. My
Yours
thinking
easier?
is
I think mine easier. No, it's okay. Don't worry. Okay? Nothing to do with thinking. It's just what is what you are focusing on mind. That means it shows that you're thinking, so it's good.
They come curve like that.
Okay, now the last one, okay? Last one. Team, this one. Okay, an object is released 20 meters above the ground Okay.
And it bounces up.
It bounce
I knew it. And it come down and it bounce.
and it bounce again.
Ping pong ball.
Okay.
Human meatball.
So this is position A,
B,
B,
A,
C, D, E,
E,
F,
F,
G.
G.
Okay, draw me the. Velocity diagram. Release it. And assume it is a perfect elastic collision, that means you can bounce back the same height.
Wow, got such thing one meh?
No, no such thing in this world, okay? In a perfect imaginative world. That means no energy is lost. Then all the
Oh, in vacuum
energy,
can, right?
no, more than that. It's the surface. Okay? It's the surface got to be super elastic. Something can be quite close. Tennis ball. Tennis ball is very elastic. Normally you hit, right, the height it drops is very negligible. If you hit on some wooden or
Down, up, down,
Yeah.
down.
Then if 如果是这样的话，那 bounce 不是forever bouncing?
yeah, and then you try the bowling ball, it bounce, right? It's very easy, okay? So it's different, okay? Different elasticity. So from the different elasticity, you gotta think about what's mean a perfect system. Okay, perfect system we give back at the same height. Can't give you more than that anyway. What is this?
So assuming that you will bounce back the same height lah.
Yeah.
Start from 0 lah. Eh no,
From
don't start from
0.
0.
I'm releasing.
I know.
Uh-huh.
Start from the middle there.
Middle there.
20 meter lah.
20 meter.
Yeah.
What do you mean by 20 meter? Come. Show me.
Just in the somewhere in the middle.
Go there and mark lah.
Where? Up, down, left, right, tell me.
Up. Yeah.
You have speed? Do you have speed initially? When I release my object?
Yeah.
At the instant when I
Yeah.
release? If I throw this, do I have speed?
Yes.
If I throw it up, do I have speed?
Yes.
If I release, do I have speed?
Have.
What speed?
No speed, man.
How many per second when I release it?
0.
When I throw up, my velocity is up, right? I have some vertical velocity, right? When I throw down, I have some velocity, right? When I release, at the inside when I release,
No, nothing.
no, you're right. Hey,
So it's
think
up to
about it.
0.
It's up to 0. Good.
Oh, so wait, this is 0.
I'm not with you in exam, okay? You think wisely.
Then it goes down.
You take down one positive, right? Good.
Yeah. I know you should go up lah, but I go down.
Okay, this point is point what? Point A, right?
Point A.
This point is point
Point B.
Point B, good.
Then point C. You also outside then the other side. Too wide.
So where's point C?
Point C is right beside point B.
Here?
Yeah. Then go up.
Wait, is point C correct?
Yeah.
Okay, fine, okay. Then go up, okay. To where? Point D, is it?
Yeah, point D.
Here?
Same level as A.
Okay, tell me. Is D correct? Because the speed is 0 right, at D.
Yeah.
Correct? Good. D is correct. A is correct. So, do I have a gradient like that?
No.
The gradient should change or not?
The gradient shouldn't change.
Gradient shouldn't change means that, is this gradient correct?
Correct.
So, this gradient must be
Equal.
wrong. You say that the constant cannot change, right? Then the gradient cannot change, right? Then you got to keep going down. Right?
Oh, so the
How come
gradient,
we go up, change value already? Right?
so the gradient can change.
So either the gradient can change, or it is not this one. Which one make more sense?
The gradient can change.
Gradient can change. Gradient due to what? Gradient is due to acceleration, you know, right?
Ah.
Gradient.
But acceleration cannot change.
Yeah, acceleration equal gravity G. Equal 10 one. So if gradient cannot change, you left one conclusion. What do you have? This is a wrong point.
Yeah.
So if it's wrong, get the right one.
Go down some more.
Go down some more.
Yeah. Yeah.
And then do I still need to join the C back to D?
No.
Don't have to join. Broken. Some weird velocity could come out. Okay. Tell yourself. Okay. Here. Hello. Look at here. Look, I need your eyes.
Yeah,
please. You say C is just now. You say C is the same level as B
Yeah.
because the speed is the same, right?
Yeah.
This is what?
Velocity.
Is the direction the same?
No.
Direction is it totally opposite?
Yeah.
B and C, right? Same speed means same y value, but they got to be different in terms of positive negative. So where is the point C? If this is let's say -7, then where is the point C? If B is at
Point C
-7,
is positive 7.
point C is +7. Okay, so point C is actually here.
Oh.
Then it will make sense to come with the D.
Okay.
Can?
Oh, and then it's parallel.
Yeah, what happened in between here? In between here is the impact with the floor, and you don't know what happened. So you don't really care about what happened.
So you don't need to draw the line.
You can draw a dotted line if you want to guide yourself. Otherwise, you just say, oh, this one disappear become this. If there's a perfect system, the B and C no loss. No loss kinetic energy, same speed. Okay. So this 7, you draw back the exactly same amount.
Oh, this is something like say like infinity lah. That draw then
Yeah.
come out from nowhere.
Yes. Okay. Why? No issue. This is a velocity time graph. It's not distance. It's not something you see. It's about how fast, how slow.
Okay.
No issue for this. Okay. So it didn't really disappear, become somewhere else, but the speed changed suddenly. It really changed suddenly. Okay. So nothing weird. Okay. So this one keep going down in this way to hit the point D. Okay. And then
Comes out
E,
from nowhere again.
F.
Yeah, it comes out.
Okay. And then come down to G. Okay. So this area in the graph, same as this area in the graph.
What's that called?
Make sense?
Yeah.
Because the displacement, right? This is a negative displacement, go down amount. This is positive displacement, up amount. So these two triangles are the same. Width is the same, height is the same.
The displacement is 0.
Okay? Displacement is 0, of course you get the same point A and D.
Yeah.
A and D. Got it? Okay, so that's how you draw all this graph. Okay? Yeah, good. That's all about kinematics. Try some questions. Okay. Try MCQ. Anything you want to ask?
I don't have a book.
You don't have a book. Any book for kinematics? You have that one, right?
The book, the question inside.
Got right?
Oh, some exercise.